to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start.
Hello everyone and welcome to day 8/9, maybe probably, of Advent of Code. We didn't stream yesterday, so now we are one day behind, but we are hoping to catch up. And it may seem as though I just woke up, but that's just because I just woke up. And David just woke up. He's having breakfast now. And he said he's going to be as quick as possible, and then he's going to join us. So before we jump into day 8 and day 9, it's finally time. And Nick is here on the chat, so hello Nick, and Nod was one. It's finally time for me to understand the solution to day 5 that uses a simple for loop. David said that he implemented it in this way and that he ran, and it took longer than our solution that was pretty much immediate with the interval arithmetic. But he doesn't know how long it took for the thing to run, maybe half an hour, maybe an hour, something like that. But in any case, let's jump in and look at his solution, because I feel like after having read the chat transcript for that stream, I was reading it more carefully, I wasn't reading it live, and I was thinking more about it. I think I finally understand, and indeed it is remarkably straightforward, because I was making things more complicated, thinking that you would need to use an iterator because you needed to compute all the input seeds at once. But Nick correctly pointed out in the chat that you don't need to do that. For each seed, and when I say each seed, I don't mean each interval, I mean just literally each seed, you could just run the whole mapping, and then for the next seed, run the whole mapping. You don't have to run all the seeds through the map all at once. In order to be able to do that, you would need to use some iterator to keep track of where you need to return to. Maybe this is too abstract. Maybe I should recap what day 5 is. It's that day in which you have some seeds, numbers, and the seeds are a base number and an interval length or a range length. So it starts at this big number, and this is the length of that interval. So there are this many numbers on this interval. So it starts with this one ending at 6, then the one ending at 7, and 8, and 9, and so on. And in the list overall, there are these many numbers. And then these are maps. Again, this is the base number, and this is the range of the map, and this is the target of the map. So this number ending in 7 turns into this number ending in 6. Then the next number ending in 8 ends in a number ending in 7, and so on and so forth. And the length of the mapping, or the size of the mapping, is this. So we are still dealing with big numbers, but if you don't try and put all the numbers in memory at once, you shouldn't run out of memory. And we don't run out of memory. In fact, we have run the code already. David ran the code, and I suppose some other people as well. What I love about this solution is that it is indeed just an extension to the solution for the first part. You can reuse most of the code that you wrote for the first part, the naive brute force implementation. I also love this idea because it is something that we have not seen in the subreddit when we were looking at other people's answers. Now, naturally, we didn't look at all of them, so I'm pretty sure that someone did that. Nick himself implemented it in another way, but someone must have implemented that in the subreddit. But it was surprising that I was overcomplicating the problem, and many people were overcomplicating the problem as well. especially if you use a more efficient language like C++, then the brute force solution instantiating every seed could very well be fast enough. Anyway, let's see what David wrote here. First, there is the parsing. That's straightforward. And then he is instantiating the ranges in the same way that we did. So he's instantiating the range in the same way that we did in the smart solution by using intervals. I suppose right here, instead of having the map, we could have done the for loop. But anyway, we are going to track each seed as it goes through the mappings, and we are going to accumulate, we are going to store not the results of all the seeds like we did in our original brute force solution. We are going to store only the minimal. So we are going to be doing the traversal, and we are going to do the logic, which is a very simple logic, but we are going to do it anyway for the minimal right in one pass. That's why we start at infinity, and then we are going to compare if the item that we get to is less than the minimum item, we store that. Then we are going to be working our way toward the minimum. But there is no way for us to stop early, because it could very well be the last number on the last range that gives us the minimum. So we don't know. There is no smart way of predicting that. So we will have to run, even if the minimum was generated by the very first seed, we would need to run through every single seed to be sure of that. There are no shortcuts here. Then for the mapping in and of itself, it is the logic that we wrote. So I can see that there are no iterators here. There are just simple for loops, as Nick pointed out several times. And this in particular was the simple for loop that he wrote in the chat. And I love when these things happen. Like, you're trying to communicate something that is super simple, but for whatever reason the other person is thinking that there is more to the problem, and then you're like, have you heard of for loops? What is going on here? Our communication isn't happening. And I guess it was one of those nights when I was just ever so slightly sleep deprived. So ever so slightly like drunk in sleep deprivation. So I was like, I cannot see through this. And really what makes it work is that we run the whole mapping for every seed over and over. So in essence, this for loop is inside this for loop. And that's what I was unable to see at the time, because I wanted to run all the mappings only once. Okay, it was you. Yeah, I see meters in OBS, so that was supposed to be working. But then that's not all. David also found this other solution using WebGL or WebGPU, because when we were looking at the subreddit for the solutions, we found some people using the GPU to do the brute force in a reasonable time. And we speculated that that would be possible because the GPU can do a lot of computation in parallel, and even the computation that is done, let's say, not in parallel, can perhaps be a bit faster, and maybe the GPU has a different memory space that would be larger, so it could accommodate more numbers if you have a fancy GPU. And this problem is very parallelizable, especially if you take this approach of not trying to run all the maps all at once. So if you use this approach of just taking one seed and passing it through all the maps, that is very parallelizable. You can just split the problem for every seed. If you want to run all the maps only once, or each map only once, then it is slightly trickier to parallelize, because for each of the maps you will have to split the problem but then you sort of have to carry that answer to the next map, which I guess is also not the end of the world. So in essence, this problem is very parallelizable. And let's see what this looks like, because it is interesting. I guess I will copy this into a JavaScript buffer, because then we will have some syntax highlighting going. So we are using a shader, which normally would be used for graphics. So normally it would be used for drawing polygons, drawing shadows and stuff like that in a 3D rendering situation. But it is, in essence, just a fast way to compute on the GPU. That's what a shader is. So you can use shaders for other purposes, including computing the mappings. And apparently, to use WebGL or WebGPU and to use a shader, you write that in another language, in a shader language. I suppose that there are like kind of domain-specific languages for writing shaders, because what I see here kind of looks like, well, it looks kind of C-ish, but it's not C. And, well, because it looks C-ish, it also looks JavaScript-ish, but it's not JavaScript either. So I suppose it's a domain-specific language for shaders. And from what I can see, you are trying to minimize the amount of work done on the shader, as in you take the part that really is slow and worth optimizing and you do that in the shader. But the rest of the program, from, I suppose they will do some parsing and whatever else they are doing, is done in JavaScript. Let's perhaps take a look at the rest of the program, and then in light of that, we will try and make sense of what the shader does. Because at a glance, I cannot fully grasp what's going on. Oh, and David is here. Let's say hello to him. Ah, I picked up the call already and it's ringing on my phone. Cool stuff. Hang on, David, we still don't hear you, but it's fine. Oh, wait. I want that to be on my external headphones. And I wonder if I do that.
Testing.
And now the stream can hear you, so...
Okay, great.
Hello!
Hello, good morning. Sorry I'm a little bit late.
That's all right, that's all right. We are all trying to wake up here. It's perfectly fine. And I was looking at the GPU solution you found. I already looked at your implementation with the simple for loop, and it is indeed much simpler.
Yeah.
But now I'm trying to make sense of, or we are trying to make sense of the web GPU stuff. And we have already determined that this is a domain-specific language for shaders. It's not something that we recognize, or I don't recognize. It looks kind of C-ish, but it's not C. And then I was going to start jumping into the main function so that perhaps the shader will make sense in that context, because just by glancing at this, I'm not really sure I get it.
Yeah. I would love to learn more about it, but I don't know. What do you want to do? I think we've got 2 to catch up on, so maybe we should use our time wisely.
Oh, you want to skip this and come back to it later?
Yeah, perhaps. I mean,
okay, then.
High level, the goal would be to just populate an array of the size that we know that it needs to be, which is the range of everything.
Mm-hmm.
And then each one would do the computation. Actually, I don't think it would be that, because if it would be an array that big size, then we would run out of memory, right? So we would have to do it within, each sub module would have to be doing however many, of a particular range, for example. I'm not sure how the best way to use the GPU would be. So yeah, I mean, there's more to explore, I guess.
Okay, so as you wish, we will come back to this later. Let's start with day 8. Woohoo! And
Let's do it.
you are driving today, right?
Am I? Oh, yeah, of course I am.
All right,
Sorry.
so
Yeah.
take it away.
Day 8. Do you have to share your screen?
Oh, wait, yeah. Yes, there. There you go.
Okay. Let me just change some. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Ah, that's convenient. Sure enough, it's full of documents, your puzzle input, and how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left or right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. Yes, graph theory. It seems like you're meant to be using the left or right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, 2 nodes stick out. AAA and Triple Z. You feel like AAA is where you are now, and you have to follow left or right instructions until you reach Triple Z. Makes sense. This is the format each node of the network individually. For example, right, left. What? What's that right, left at the top? Okay, well, I guess we'll find out. Starting with AAA, you need to look up the next element based on the next left or right instructions in your input. For example, in this example, start with AA and go right. Ah, I see.
So there are 2 elements.
Wait.
This is the left, this is the right.
Yeah. Right, but it says RL at the top instead of LR, so is the first column right? Is that one of their tricks?
No.
Uh,
It says
go
RL,
right.
so it means you're supposed to go right and then go left. So you start at AAA, you go right. Then you are going to arrive at CCC, and then you go left. And then you're going to arrive at ZZZ. End of story.
Ah, okay. By choosing the right element of AA, CCC, then L means to choose left. Yeah, as you said. Okay, you just explained this exactly. Of course, you might not find ZZZ straight away. If you run out of left or right instructions, repeat the whole sequence of instructions as necessary. RL, and so on. For example, there is a situation that takes 6 steps to reach ZZZ. How many steps are required to reach ZZZ?
Yeah, let's read through this. So I started AAA, I will take left B, left A, R B. Then left A, left B, R B. Okay, I can see how that amounts to 6. And let's take a peek at the puzzle input to see if there are any strangeness.
Oh boy.
No, there are no outputs that stand out to me, or inputs that stand out to me. So I will wait for your link to the live share, and
Yes. Give me 1 second. I'm just doing that.
and while you're doing that, I will start to speculate how I would solve this. I perhaps would create the whole graph in memory because it is small enough that it fits. Then I would create this. I would just store it as perhaps even a string and an index into the string, and I would do modulo arithmetic so that I can add one, go to the next, go to the next, go to the next, wrap around, go to the next, go to the next, go to the next. And then I would just brute force and simply start in the beginning, start at AAA, and find my way through. And there is AAA, and there is ZZZ. And yeah, I think that's what I would do. It looks straightforward enough that, at least for part 1, it will work.
I am guessing that part 2 is shortest path.
So without instructions at the top, ignore the instructions at the top, how can you get there as fast as possible?
Something like that.
I see. Yeah, that could be fun.
Dijkstra.
Yeah, that's what I think. Some recursion.
Okay.
All right, I'm ready. And this is not day 7. This is day 8.
Oh, I just don't have day 8 in here. Okay, that's my bad. All right. So, could we paste in the puzzle input?
All right, I can take care of that part.
Actually, we can just do the example for now. There's 2 examples, which is kind of them.
Duke. There.
Yeah, this is too big for us to do it manually, but it's not far off. So for line in input.split lines, is it split lines? Is that a function? I didn't even know that.
I have seen that in previous solutions, yes. That rings a bell.
Okay. Okay, sounds good. So, I'm just going to ignore empty lines, and then I would do I'm just going to say if line dot, is it contains, or oh yeah, it's if then we can add to graph.
How do we plan on representing the graph? Do you have an idea there? Because I have.
Adjacency list.
Adjacency list.
Yeah. And then the final one is instructions, right? So instructions, graph.
I find it cute that they're making this generic so that the RL could appear anywhere in the input, even though we know it's in the beginning. So we could have just split by 2 new lines in a row. But continue. Your solution is more adaptable.
I just I couldn't be bothered to work out if I get the right number of new lines or whatever, and like, so this works.
Yeah, be flexible in your inputs and strict on your outputs, right? That is a law somewhere.
Somewhere, yeah. So let's do graph because it's more fun. So I think it would just be could use regex, but that's not my style. I'm gonna say node children, and then yeah, I think that works.
Yeah, it's kind of silly to write it this range. I would just do that, but I just did it. No, wait a second.
You need to get rid of the last.
Actually, you want this.
Paren.
Children is all this string to the right of the equal sign. Oh, but you want to take out the parentheses. Ah, I see it now.
Yeah.
Okay, now I see it. Are you all of you appreciating the construction work that is happening here as well, or is it just me?
I think that's correct. I think that's all I need.
I agree.
Left, right, graph.
I agree.
And then instructions. Actually, it's going to be an array.
Can we be cute and say that R translates to 1 and L translates to 0? So in the list of instructions, we can simply use the instruction as an index into the tuple?
That would be cute. Yes, that would be cute. Okay. We're gonna do some lovely list comprehension here.
Yes, I think that as extra exercise, we can use as many list comprehensions as we can. Like, let's just use them all the time.
There we go. I think that's the main part, isn't it?
Can we print the graph and print the instructions just to make sure we got them?
Sure. Huh. Oh yeah, sorry, whoops.
I see. So we got it.
Yeah, that looks good to me.
And we don't need to print the line as it comes in. I'm gonna remove that. That's
Yeah.
just extra.
Then, what was the goal? Was to find out how many steps it takes, right?
Yes.
So, I'll just do like root is A, and then while maybe I'll just do node.
Yeah, call it node. It's only the root in the beginning.
Not equal to Z.
And while you're doing the traversal, I will be doing the counting. So, number of visited nodes. Okay, stop that. I feel like editing the code simultaneously is not always the smoothest experience because
Yeah.
keep overriding my changes.
Yeah, exactly. And also, I think number of visited nodes, we can just call that I because I need that anyway.
Wait, what? Why? No. Why do you need that?
Because I need it here. I need to find out which instruction I am going on, right?
Yeah. Right. Okay. You can call it I if you wish.
I will.
All right then. Oh, that is very nice to reuse this notion of I. I like that. I would have kept that as a separate thing.
Is that right? That's
Let's
right for this input, is 2.
Yeah, I agree with what you wrote.
Let's have a look at the slightly more difficult 6 input where it repeats.
Let's. I can take care of that if you want.
Thank you.
Ah,
Oh, I'm so annoyed. I forgot to enter the answer for day 7.
would you allow me to enter code on your terminal or to use your terminal?
Oh, yeah, sure. Sorry, I didn't see that pop up. Try again. Can you request again?
No, I cannot request again. Can you just run the program, please? I have put
Oh,
the
yeah,
log in
sure.
place. 6. All right, we are good. So now
Okay.
I will paste in the real input. Can you please run the program? All right.
Yep.
And then drum roll. Boop. That's the right answer. Woohoo!
Hey, that was smooth, I think.
Yes, I'm very happy with this.
Very nice. Guess there wasn't really anything that particularly beautiful about Python in this scenario? It's very straightforward, isn't it?
It is very straightforward,
Language.
but now we will have some access that will act as jokers, and we will have
Oh,
to
yeah.
split the world.
Is it Jokers? Okay, I'll have to read. I haven't read it yet.
No, I
The
haven't.
Sandstorm is
I
a
haven't read it yet, but I saw the example and I know where they're going. I'm pretty sure.
Okay. All right. Oh, ghosts. They did mention ghosts. Okay. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space and time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously ended up at nodes ending with Z. What?
What? It's more complicated than I thought.
Okay, hold on. Let me read that sentence again.
Okay.
All of the nodes ending with A is equal to the number of nodes ending in Z. So if you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time. Right, all the paths. Right, so there's three possible paths. All right, for example, here there are two starting nodes, 11A and 22A, because they both end with, right, yeah. So you can follow any of these. Because they both end with A, as you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes you're currently on. Use that instruction to simultaneously... Yeah. Repeat this process until all the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node, and you continue as normal. In this example, you would proceed as follows. So step 1, you're in 11A and 22A, 11B and 22B, blah, 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 blah. You follow it through, I believe them. You end up entirely on nodes that end in Z after 6 steps. How many steps does it take before you're only on nodes that end with Z? Do you end up on those nodes at the same time? Or as soon as you end up on one which ends in a Z, you stop that path? And
you don't stop that path. You will continue to carry all of them through. If one of them finds a Z but the other doesn't, well, that's too bad, because they're going to keep going again until all of them simultaneously reach a Z node.
Yeah, so that's if only some of the nodes you're on end with Z, they act like any other node.
Yeah.
Okay. All right.
So it is simpler than I expected, because I was expecting us to have to use the axes as jokers, and then we would need to split the universe a lot more. In this case, we are not splitting the universe at all. We are just running the program simultaneously more than once. It's not too bad.
Yeah.
We will just have a list
Could
of
we-
our spots where we are, and in our loop we are gonna do all the steps, and then after the loop we are gonna check if we reach the final destination. So it's not terrible.
All right. I'll do what you said.
But we don't see any access here, so it's curious to me that they were using access there. I thought they were just using access as special letters. They're not. They're
Oh,
not at
yeah.
all right.
So we need to find all of them which end with an A.
We
Can we verify?
first need to do that to know our starting condition. Yes.
Yeah. Well, I guess one of them will be an A.
That would be right.
So
Some. I think we need like a list of nodes where we are. Oh, wait, before we continue, do you want to create a copy of this file? Because we are probably going to change the code in a way that doesn't output the answer for part 1 anymore.
it's fine. I'll just leave this part 1 part here, and then we'll just do part 2 in line below.
Okay. I'll let you do that. I will even remove my line and then you can drive.
So what I'll do is I'll just say this is part 1. And then I'll do so here this was going to be a normal function, but instead we can make this into a list comprehension.
Oh, I didn't see that coming. My brain doesn't work that way. Okay. By the end of this, I will like list comprehensions. You'll see.
Yeah, I definitely wouldn't do a list comprehension for this normally. I think it's way too much.
Thanks for indulging me in my challenge of comprehending lists.
Yeah. I actually don't know the best way to do this because here we're actually kind of filtering them out, right?
Okay.
So it's normally a one-to-one mapping. So we're going to have to do like a secondary filtering step, which what we could do, yeah, I mean, we could add it to a set. I believe you can create a set just by doing like, you can do a list comprehension set like this.
Why do you want the nodes to be a set?
I don't. It's just how am I going to do the filtering out? You see in the list comprehension. All right, I'll show you what I mean. There's also probably a way to iterate the keys. I don't know. Doesn't matter. And then k if k dot ends with a, else none. And now I need to filter out all the nuns, which is why a set might help. Or you see what I mean?
You can map, but you cannot map reduce. Got it.
I mean, should we Google this quickly? List comprehension where only some values.
Is there such a thing as a list comprehension with a flat map?
Yeah, you can do it. You do it like this. You put it here. How's that?
Wow. Okay. I actually like the fact that you can do the filtering. It's very cute.
Yeah.
Does it work though? Can you print that?
I'll print it. Yeah.
Here in the console.
No, ends with. Did I mean ends with? Yes, I did.
Okay, key error.
Okay, that's fine. That's just that's a different error, but you can see it got the right nodes. 1182A.
Yes, I see that. I see that over here. All right, cute. I like that.
I don't know why part 1 is failing though, because it should still be the same.
Well.
Okay, well, we'll get to that. That's fine. So find the root nodes. What are we doing again? Oh yeah, we're just traversing them. So we still need I equals 0. And while
we want to do a list comprehension on the nodes with like true and false and stuff like that. Oh, okay, that works as well. I was gonna do a list comprehension, you see.
Oh, we'll do a list comprehension here. Oh, they're doing it for us.
I will do a list comprehension. I will attempt a list comprehension, people. Observe as I list comprehend. I will want to have any element at all for node in nodes if node ends with z and I will check the count. Is that how I check the count? No, it's len. Len equals 0, for instance. Or actually less than, to be able to put this in the while loop, less than the length of the nodes. How about this line?
That's nice.
No, it sucks.
Yeah, I think it's a little bit more expressive with the all, but it is less comprehensions.
It is.
I'm wondering if, wait, why 1, 2, 3 for node in nodes?
Oh, it
Why 1,
doesn't
2,
matter
3?
this value. I'm just looking at the length of the list anyway.
Ah, I see. Yeah. Yeah. Yeah, that works too.
Yeah.
Should we chuck it in? Let's chuck it in.
Keep your lambda. Keep your version.
Are you sure?
Keep yours. Yes. No, I mean, as in, don't throw it away. Comment or something.
Ah, okay.
Yeah. Keep it for future reference.
Let's just do 1. Or just do node, and let's do X.
Okay. For maximum unreadability. Great.
I think this is more readable if you do X, because it's clear, like, you don't need to think about what this thing is. You just always, if you always use X, you always need to think about the context of the mapping.
Okay.
I don't know. I tend to use X for these, like, because it's always, if it's a very inline thing, it's only ever one line, so it's always very obvious.
I agree. In general, I would say the smaller the scope of a variable, the shorter its name can be. All right.
Yeah.
So we are doing a list comprehension to do the mapping. And then we are incrementing one.
Which is nice.
Incrementing I. And then by the end, we print I.
No, we print. We print I. Yeah.
And that's that.
Yeah.
Are we getting the right answer? The right answer in this context is 6.
Oh, what happened there?
What happened where?
How do you do the region thing in Python?
What is the region thing?
You know, in VS Code, you can do regions.
What?
So you can do, you can like comment out parts of the file so that do you see what I mean?
No.
So, I don't know how to do it. Region. Fold all regions. Yeah, so basically you can mark parts of the file as like this region and that region, and then it allows you to fold and unfold those regions as if they're like blocks.
Oh, wow.
So I like to label them with region, and I think in you do like this.
Well.
And then it comes, but that was in JavaScript. Maybe it's not working here, or I'm not sure.
I didn't know that was
Anyway,
a feature. Good to know.
Doesn't matter.
What is the result of the program?
Is it throwing?
Isn't it for
Yeah,
part
throwing.
1 that we broke somehow? I'm going to comment out part 1. Try
Okay.
again.
Okay. Oh, it's an infinite loop.
It's an infinite loop. Huh. We have proved that the first part here that finds the starting points works. That's what the nodes are here. Then this list comprehension thing that we are doing for checking the number of winners. If you want to change it to X, change it to X. Try again.
That's a very good point.
All right.
Hey,
Now for the
Nice.
real input. Run again.
yep.
And we are dealing with only 2, 4, 6 nodes.
That's taking some time.
Oh no. Oh no.
Too many list comprehensions? Do you think there's an issue? Also, it annoys me that part 1 is failing. I want to fix it.
Maybe this list comprehension that we are doing here is slow because it is going over all the nodes for...
There's only 3, though.
Well, no, I mean, it is going over all the nodes here in the input. It's going over all of them every time. We could use your version, which I think will be smart enough to stop when it can prove that not all nodes end in Z. So it's going to stop the search early.
It will, but there are only 3 nodes that we're checking each time. It's like, it's not that much different checking 1 or checking 3.
No, we are going
But I
over all the
agree.
nodes every time.
Yeah, but there's only 3 nodes in there.
No. There are not only 3 nodes. What do you mean?
No, this node here is just 3 starting nodes. Oh, sorry, it's not 3. It's 1, 2, 3, 4, 5, 6.
Yes, but
6 nodes.
for each of the 6 nodes, it's going over this whole list.
No.
Oh, it's not. You are right. I am silly.
It's just checking 6 nodes. There might be some other issue in our program.
Do you think that there is an edge case somewhere that makes us spin around? Do you think that Nick is laughing at us in the chat?
Probably.
Oh, hello, Bo. We finished days in 89 2 minutes ago. Day 9 was a lot of fun. Day 8 can be a pain depending on your domain knowledge. So you could do day 9 first. And
That's okay. We've done... I think we're here. It's just like there's some either minor bug or... Could there even be a more efficient way of doing this?
well, I suppose there could be. How about, instead of actually running the problems in parallel like the description kind of leads you to do, how about we run each of them individually and we find the first ending node in Z and we stop. Or not the first. We find all of them. So we just keep running and we find all the possible endpoints. At some point we are going to cycle, right? Because there are only so many nodes. At some point we are going to end up where we started, for sure. So we can do a full loop around, find all the end nodes. Then we could, that's for each of the starting points. Then we could use the minimal multiple that is common between all the possible answers. And that is going to give us like the place where all of them meet. Okay, I just said a bunch of things, but does that make any sense to you?
Where they all meet? No, that doesn't make sense to me.
Okay, so let's take this one step at a time. First of all, do you agree that if you keep following the rules, you are guaranteed to end where you started at some point? So if I am using 11A, the rules are left, right, and if I just keep going, I don't stop when I see a Z, I just keep going, eventually I'm going to end up at 11A starting at the beginning of the instructions.
Yeah.
Okay, because there are only so many nodes and only so many instructions, so you're guaranteed to end up, or to cycle. You're guaranteed to cycle. So my proposal is, you go...
That's... yeah. Detect the cycles, first of all, I suppose.
Yeah, you first to detect the cycle is easy enough. You just know that you are back to where you started and you're back in the beginning of the input. So do that, what I just said, go over the whole cycle, and on a side table, keep note of how many steps you took when you found a particular endpoint. So if you ever get over here, you're gonna take note. Oh, it take me three steps to get here, and then you go continue. You eventually land here, and you took 4 steps, and then you take note. I took 4 steps to get here, and then you continue, and for some reason you end up here again because it may happen, right? You may visit the same node twice, so you take note. Oh, it took me 4 or 16 steps to get here. And then you run some more and maybe you land here. And then you take note. Oh, it took me 23 steps and I got here again. And then you keep doing that until you reach the end.
And then you find the lowest common, right.
You got the idea.
Yeah, got it. Yeah, got it. Okay, so...
The advantage of doing that this way is that you will not have to keep... Because the idea is if not all nodes reach the end at the same time, you're going to have to keep spinning. So it means that you may go over the whole cycle multiple times for a node. But with this other strategy, you are guaranteed there is a limit. You are only ever going to run one full cycle.
One cycle.
At most.
Okay. So for that, part 1 is working again, by the way, which is good.
What
and I've slightly updated. I don't know. I just uncommented it, and that works. So that's good. And then I've slightly changed this, so we're still using a list comprehension.
Okay.
But it's instead we still use the all.
And then we use the true. Okay. I love it.
Just syntax stuff. But okay, so changing how we're going to do this. I like this way as well. So we're going to do like iterate until cycle is found for each root. Keep track of all the end node indices.
And the number of steps it took to get us there.
Well, no, isn't it just isn't the indices the same as the number of steps?
Okay, if you want to think about it that way. Okay.
And then, is it the lowest common multiple?
Yes.
Yeah. Of all the end node indices. I guess. So do we actually just need to stop on the first one?
We must not stop on the first one, because it may be the case that to find a solution, we will need to go around the cycle a bunch of times.
Yeah. Okay, so I'm going to comment this out.
I wish that the brute force solution would have worked. Can we just take
nice.
a look at it again, because maybe we have an exponential?
I'll tell you what, I'll leave it running. And also I think
I'll first run it again, because then we are gonna see the number 6 just to double check that we didn't introduce any exponentials.
Yeah.
We get
now the AAA is failing again, the part 1.
Okay, I'm going to comment on part 1.
Oh, the reason for that is because AAA is not found in the part 2 input?
Yeah, that is the case.
Is that expected?
That is expected because this is a small example given for exclusively part 2.
Right, okay, that makes sense. Okay, but we're meant to be... Okay, so comment out this. Because we want it to run, right? Oh, you want this to run first?
Yes, I want to run this and see a number 6 again to make sure that we don't have anything silly. And
part 6.
I will comment it out now. And then we leave it running as we work on the solution for the full problem. Because the brute force solution, I wish it worked.
Yes, okay. And run. Okay, it's running.
Thanks.
Okay.
But now we can proceed.
Now we can proceed. Okay. So
And it's not even the least common multiple of all the n node indices. It's not all of them, because you don't want to reach all of them. You want to reach the closest. So let's take a moment here to think this through, because it may or may not be the case that it's possible to use this approach at all. So suppose that you wanted to, suppose that we know that in the n configuration, we will have reached the first n node for each start node. So if 11a ends in 11z and 22a finds 22z first, then those are the solutions. Then you would want the least common multiple between the number of steps in 11a and 11b, or 22a, sorry, 11a and 22a. But if it is the case that 11a is going to end up at 22z, but it has been in 11z before, then we actually want the least common multiple between 11a, 22z, and 22a, 22z. So I think that we don't want to simply take all of the nodes or all of these magic numbers we are going to collect along the way. We don't want just all of them. We want to try every possibility and see what is the minimum. So we will have to try.
Yeah.
Did 11a in the optimal number of steps reach 22a? Maybe it has reached 22z. Sorry, 11z. Maybe it has reached 22z. And 22a, maybe it has reached 11z in the optimal configuration. Maybe it has reached 22z. So we will have to do all possibilities. But how big of a number we will end up with?
yeah,
I suppose
So it's
enough
like-
that we can do this traversal.
I think if I were to write a list comprehension of this, it would be something like LCM of X, Y, Z, and then now n node indices is going to be something like not permutations but probably combinations.
Yeah, because order doesn't matter.
Yeah, but it's not quite going to be n node indices like that. It's because it's going to be
Yeah, we don't want to combine all the n node indices into one flat list. We want to keep them separate per start node.
yeah. It's not this. It's not combinations. It's I think it's going to be for X in n nodes 1, and then how do I do a nested list comprehension? Something like, yeah, that. I think it's going to be this. I guess we'll find out. But let's do the first part, which is the easier part, right?
Yes, and I suppose we will not be able to do the whole problem today because I will need to leave in about 10 minutes.
Oh, really?
Yes,
Okay.
yeah, and we will start again tomorrow, or we'll pick up from where we left off tomorrow, and then we'll have 3 puzzles to work.
Oh man. Okay. All right. So find end nodes. Node if while node not equal. So we'll just take start or root.
I like that.
Then we can go through it and do that, and then end node indices ready, and then if node dot we probably need to do this before, don't we? Find end nodes, and then we can do, we'll take this very quickly. And then end node 1 equals I guess we don't need to pass through the instructions like that. And then I'm gonna trust Copilot on this.
That is correct, by the way.
And then min iterable argument is empty, so I think I need to do this maybe. Got 0 arguments. That's strange. What are these? What is this, first of all? Did you do some fixes up there?
No, I need some help thinking through this because it's complicated to do Boolean expressions. It's complicated for me. But finish what you're doing and then you can come back and help me.
Okay, end nodes 1. End nodes 1 is empty, so it found no M nodes. And I% not equal to 0. I think we do want to repeat the instructions though, Leandro.
No.
Like
So
it might-
yeah. The problem that I'm trying to solve with this subclause is the following. We don't want to simply stop when we have reached the root node again. We want to stop when we have reached the root node and we are in the beginning of the instruction list. Because otherwise we could keep running, because we could be, for instance, in the input example on line 780, we could be reaching 11A again, but this time we are here. So we are going to go to the right. We're going to visit XXX. How sexy. So we want to use this
yeah,
information
but
here,
this
but
is
I'm,
exiting
the
straight
problem
away.
I have is I cannot for the life of me figure out if I want different or equal, and I don't know if I want and or. So that's your task, to help me out with this part.
I have a feeling. Okay, just go with me a second. Okay, no. Because when you first run this, I is going to be 0, so this is going to be 0. And node will be equal to root. So it can't be 0. If you see what I mean.
No, I don't. I'm having a completely brain fart here. I cannot for the life of me figure this part out. I just know that we need this clause there. The and the or and the equal or different, you are going to have to puzzle out because I cannot.
I don't see why it's not finding any nodes right now, even without that. It's just exiting. Oh yeah, because the node is equal to the root on the first iteration, right? And what is your reasoning behind this? Is like, even if we reach the first node, we might not have gone through all the instructions. But why does that matter?
Well, come back to the example.
Oh yeah. I'm with you. I'm with you. Okay, so I think we're gonna need the I.
I think what we need here is not a while, but a do while. Because in the beginning, we will be in the state where we want to end, but we will want to take a first step. So can we change this into a do while?
Yeah, we can. But the only way to do that, there isn't a do while in Python, so you have to do while true and then exit afterwards.
Which is fine by me.
So,
it's in essence the same.
Okay.
Who cares about structured programming? All right, so we have something.
If node is at the root and
Instruction is equal to 0. Okay, with this, it's much easier to reason about. Now my brain works again. Thank you.
It's still taking a very long time.
Oh, you're running it.
I don't even get all the nodes.
Well, maybe...
Let's do it for the small input, I suppose.
Wait, you're running on the big input?
Yeah.
No. Okay, I'm commenting out the small input. Can you run again?
Yeah. Seems to be running for a very long time.
Maybe my idea that it is always going to be that there always going to be a cycle is flawed. I don't think it is, because everything about the problem is finite. Maybe it is flawed. But maybe we just have a bug. But maybe
Yeah.
there are too many of these. To go through the cycle, we just work too much. And if that's the case, that we just work too much, then perhaps we would need to step this find end nodes. We would need to step all of them together. So we will be running all of this simultaneously, and we will be finding the potential end nodes simultaneously, and we will be computing the LCM for all the combinations simultaneously. And once we find one that is small enough in the first cycle, I think we are good to go. I think we have our answer.
You know what would be cool is if we made find end nodes into an iterator, and then we could yield them as we go, and then we wouldn't need to change this code very much.
I see. Oh shucks. But come on, this graph is small enough that it should find all the nodes.
Yeah, it should. I think there's a bug.
There is a bug.
Okay, so if it's equal to the root, then we can break. That makes sense. And then, but we could get to the root, but not have finished all the instructions yet.
Yeah.
So why don't we just say I is greater than or equal to len instructions? Would that do it? Does it have to finish on 0? I suppose it does, because otherwise it wouldn't be a complete cycle.
I don't think that that's our issue. I think that our issue is somewhere else.
Are we on the sample input?
I think that, first of all, I think we should increment this after.
Oh, yeah.
But that's inconsequential. It should terminate either way. I will want to see the nodes here. Can you run this, please? So the nodes are 11A and 22A? Or is there any other print before? No. So the nodes are right. And even find end nodes of 11A is not terminating.
Yeah.
So there is a problem here. There is a bug here. Come on. This graph is too small for this not to work.
Yeah, there's no way. Let's I guess let's print I node.
Yeah.
Well, wait, hold on. No, I needs to. Otherwise, this will exit on the first iteration if I plus 1 is not above here, right?
No, because we have already moved the node. But you are right. If we are moving the node, we might as well move the I as well. Okay. Yeah, I'm with you. Yeah, I agree. I'll put the I above. I put the I above.
Okay.
Can you run this?
Okay, so
this should surely work. We keep visiting nodes. So there is a problem with our stop condition.
11B, 11Z, 11B, 11Z, 11B, 11Z. We're not getting back to the cycle, I guess. I guess you could have a cycle which doesn't go back to the start node. Why don't we just keep track of the scene nodes and just stop when we have a cycle? That might not be the case though, because, well, we have a cycle, we can keep track of, if we keep track of, like, scene is a set of tuple.
No, that shouldn't be
No,
necessary. We should be. Is there a problem with equality? Is there anything funky going with equality in Python? We have seen before that equality in Python behaves reasonably well, but is that the case that we can trust this? Can we always trust equality on strings to work the way that we expect?
Yeah.
I see what you mean now, and you may be right. There is always going to be a cycle, but it's not guaranteed that the cycle is going to revisit the first node, because if I'm drawing the graph here with my hands, it could be the case that we start somewhere and then we go in a cycle.
Yeah.
I see what you mean. Aha! I think we unlocked this, and with this cliffhanger, it's time for me to say goodbye. Can you promise you won't finish the problem without me?
Oh, that's so difficult. Okay, yes.
I'll see you tomorrow again. What time is good for you?
Same time?
All right, so tomorrow at 10 a.m. UTC, we'll be back to continue on this.
If you're available later... No, that's okay. Let's do tomorrow. We got 3 problems to do tomorrow.
Yes.
We're going to smash through them, I'm sure.
Tomorrow, I don't have any time constraints that I can remember. So, yeah,
Okay.
Tomorrow, I see you here to continue this. It's such a fun problem. I'm loving. If this idea works, I'm very happy about it. And
Yeah.
And Nick was saying on the chat, you just made the wrong assumption that it would revisit your start point. Okay, we figured this out. So thank you, Nick, Nod1, and Bo for joining us on the chat. And a very warm thank you to David for joining me on this ride. I'm having the time of my life here. And I'll see you again tomorrow at 10 UTC for more of this. 3 problems in a row. It's going to be fantastic. We are going to be here all Sunday.
All right. Have a great day, Leandro.
You too. Bye-bye.
Bye-bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.